Now this is in the form of cos x plus cos y form. We are supposed to prove this. This is equal to your root 2 cos x. Numerator and denominator, you will get the same value. When you take the reciprocal of the denominator, the term repeats here 2 times, so it is whole square. In the second quadrant, your cos function is negative, but the function changes to cofunction. Remember the formula of sin 2x? Sin 2x is nothing but 2 sin x cos x. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So in our previous sessions, we have learned all the identities of trigonometric function. Let us start application of those identities from now on. Yes, we'll be dealing with the problems of trigonometric functions in today's session. So, trigonometric functions problem may carry for 3 marks question and as well as 5 marks question, where you will use the identities of sum and difference, multiple angles as well as transformation formulas. So, before practicing the problems, keep a list of all the formulas of your trigonometric function, so it will be very easy to remember. Here we have a first question. Tan 3x, tan 2x, tan x is equal to tan 3x minus tan 2x minus tan x. All these questions comes in the form of proving. So they'll give the questions in the form prove that tan 3x, tan 2x, tan x is equal to tan 3x minus tan 2x minus tan x. So you can take your left hand side to prove right hand side or right hand side to prove left hand side, or sometimes you can prove both the equations simultaneously. Now first we have tan 3x on both sides. So let me take tan 3x as a sum of 2 angles, that is in the form of tan 2x plus x. If you apply the formula as tan x plus y, what happens here? This is tan x, which is tan 2x plus tan x whole divided by 1 minus tan 2x tan x. Now here we have tan 3x. So cross multiply this. What we will get? Tan 3x into 1, tan 3x minus, when you multiply with this, it becomes tan x, tan 2x, tan 3x, which is equal to tan 2x plus tan x. Now shift this to your right hand side and shift this to your left hand side. What happens? Tan 3x minus tan 2x minus tan x is equal to tan x, tan 2x, tan 3x. Very simple proof. So this is what you are needed to prove. So you can see here I have taken tan 3x as a sum of 2x plus x. Just apply the formula of tan x plus y. Then cross multiply, shift the terms to your left hand side and right hand side. You will get the given equation. Next question, we have cos pi by 4 plus x plus cos pi by 4 minus x. Now this is in the form of cos x plus cos y form. We are supposed to prove this. This is equal to your root 2 cos x. What is the formula of cos x plus cos y? This is equal to 2 cos x plus y by 2 cos x minus y by 2. So the transformation formula of sum to product, we will apply it. So let me take my left hand side. What is my left hand side? That is cos pi by 4 plus x plus cos pi by 4 minus x. Now this complete term you take it as x, this complete term you take it as y. So according to the formula, it is 2 cos x is pi by 4 plus x plus y, which is this, plus y is pi by 4 minus x divided by 2. Similarly, cos x minus y, cos x is pi by 4 plus x. When you take minus, change the sign, minus pi by 4 plus x divided by 2. Now 2 cos x and get cancelled. So here you will get 2 pi by 4 divided by 2. Here pi by 4 minus pi by 4 get cancelled. So you will get 2 cos x by 2. 2 get cancelled, 2 get cancelled. What is the value of cos pi by 4? It is 1 by root 2. And this is cos x. So 2 is nothing but root 2 into root 2. Correct? 2 is root 2 into root 2. So when you cancel the root 2 here, or when you rationalize the denominator, you will get this as root 2 cos x. That is equal to your right hand side. Hence we proved it. Once again I'll explain here. We have cos x plus cos y form. So cos x plus cos y is nothing but 2 cos x plus y by 2 cos x minus y by 2. Apply this transformation formula here. Here this x plus y by 2 x minus y by 2. Then you will get 2 pi by 4 which cancel with the denominator 2. Here you will get 2x again cancels. So it is cos pi by 4. What is the value of cos pi by 4? 1 by root 2, and this is cos x. 2 by root 2 can be written as root 2 by rationalizing or by cancelling. So you will get your right hand side part. Next we have tan pi by 4 plus x. Tan pi by 4 minus x is equal to 1 plus tan x by 1 minus tan x whole square. First, let me take my left hand side. So that is tan pi by 4 plus x, again tan pi by 4 minus x. Now this is in the formula of tan x plus y. This is in the form of tan x minus y. Apply the formula. What is the formula for tan x plus y? It is tan. So tan x plus y is your tan x plus tan y whole divided by 1 minus tan x tan y. And tan x minus y is vice versa. Numerator negative, denominator positive. So if we apply this here, it is tan pi by 4 plus tan x whole divided by 1 minus tan pi by 4 tan x whole divided by denominator. Now tan pi by 4 minus tan x whole divided by 1 plus tan pi by 4 tan x. Now here we have tan pi by 4. What is the value of tan pi by 4? It is 1 plus tan x. And denominator, if you put tan pi by 4 is equal to 1, this becomes 1 minus tan x whole divided by, again this one, 1 minus tan x whole divided by 1 plus tan x. So this is in the form of a by b over c by d. So you can cross multiply. So this becomes 1 plus tan x by 1 minus tan x into. So take the reciprocal of this here, which is 1 plus tan x divided by 1 minus tan x. That is equal to 1 plus tan x by 1 minus tan x whole square, which is your right hand side. Very simple proof. Apply the formula of tan x plus y, tan x plus tan y by 1 minus tan x tan y, tan x minus y by 1 minus tan x tan y. So this is what you will get. Numerator and denominator, you will get the same value. When you take the reciprocal of the denominator, the term repeats here 2 times. So it is whole square. Now again, this can be treated as one more identity. That is tan pi by 4 plus x is nothing but 1 plus tan x by 1 minus tan x. Tan pi by 4 minus x is your 1 minus tan x by 1 plus tan x. That can also be taken as a short form, which is taken as an identity again. Here we have the next question. Cos pi plus x, cos minus x, cos pi minus x and cos pi by 2 plus x. Let me take my left hand side. LHS is equal to cos pi plus x, cos of minus x whole divided by sin pi minus x cos pi by 2 plus x. Now all these are allied angle. Remember the allied angle? So pi plus x, pi minus x, pi by 2x, pi by 2 minus x. That is, so You have 4 quadrants. So 0, pi by 2, pi, 3 pi by 2. Now look here. So whenever the ratio is with pi by 2 or 3 pi by 2, function changes to co-function. If it is with pi or 2 pi, function same. It remains the same. The function will not change. So remember this property. Now cos pi plus x. Pi plus x means it lies in the third quadrant. So in the third quadrant, cos is negative. So I'll write this as minus cos x. What is cos of minus x? Cos of minus x is always positive. That is cos x. Whole divided by sine of pi minus x. We have sine pi minus x. Pi minus x means it comes in the second quadrant. In the second quadrant, sine is positive. So therefore, your answer is sine x. Cos pi by 2 plus x. Pi by 2 plus x means again it comes in the second quadrant. In the second quadrant, your cos function is negative, but the function changes to co-function because you have the value pi by 2 here. When you are adding with 90 or 270, that is odd multiples of pi by 2, the function changes to its co-function. So for cos, it changes to sin x. But coming to the sine, cos function is negative in the second quadrant. So this is minus sin x. Now when you multiply this, minus cos square x by minus sin square x. We know that cos by sin is cot. So cos square by sin square becomes cot square x, which is your right hand side. Hence we proved it. Next we have similar property. So cos 3 by 4 plus x minus cos 3 pi by 4 minus x is equal to root 2 sin x. Now this one you take it as single term and this as single term. Cos x minus cos y formula, which is minus 2 sin x sin y. So apply the formula now. So here LHS, I am taking this, I am applying the transformation formula directly. Cos x minus cos y means minus 2 sin x plus y by 2, sin x minus y by 2. So this is minus 2 sin x 3 pi by 4 plus x plus 3 pi by 4 minus x whole divided by 2 into sin 3 pi by 4 plus x minus you are doing. When you have two terms, change the sign and write. So it is minus 3 pi by 4 plus x. Or you can write it in brackets first, then apply the sign later. So now you have minus 2 sin. Here x and x get cancelled. You will get 2 3 pi by 4 whole divided by 2. And here sin 3 pi by 4, 3 pi by 4 get cancelled, 2x by 2. 2 get cancels here. You have minus 2 sin 3 pi by 4 into sin x. So we have 3 pi by 4. So I can write this as pi minus pi by 4 in the form of allied angles, which will give the value of 3 pi by 4 only after solving this. So I'll write this as minus 2 sin pi minus pi by 4 into sin x. Again, pi minus pi by 4 means it comes in the second quadrant. In the second quadrant, your sine function is positive. So therefore, it is minus 2 sin pi by 4 into sin x. What is the value of sin pi by 4? Your value of sin pi by 4 is 1 by root 2 sin x. Again, as usual, you have 2 by root 2 form, which will gives you minus root 2 into sin x, which is your right hand side. So all these problems uses one of the applications of allied angles, sum and difference of angles, transformation formulas, multiple formulas like that. So before solving all these problems, you have to learn all those identities of trigonometric functions. Now again, look at the problem here. We have this in the form of cos x minus cos y. Apply the formula of cos x minus cos y transformation formula. Then you will get this cancel 2. 3 pi by 4, I doesn't know the value of 3 pi by 4, but I can take it in the form of allied angle, that is pi minus pi by 4, which is same as 3 pi by 4. Now this is in the form of cos pi minus x. Now this is in the form of sin pi minus x. So sin pi minus x means it comes in the second quadrant. In the second quadrant, function is positive. Sin function is positive. So sin pi by 4, you will get value of sin pi by 4 is 1 by root 2. 2 by root 2, after rationalizing or by cancellation, you will get it as root 2 sin x, which is your right hand side. Next problem, we have cos square 2x minus cos square 6x. So first let me consider my LHS part, and that is equal to sin 4x sin 8x. I have to prove now. So my LHS part is cos square 2x minus cos square 6x. I doesn't know any transformation formula when it is in the square form. So I'll split it. We know the identity, that is a square minus b square can be written as a plus b, a minus b. Correct? The same thing I'll apply here. So this is now cos 2x plus cos 6x into cos 2x minus cos 6x. Now 1 is in the form of cos x plus cos y. And the other is in the form of cos x minus cos y. Now transform it. Cos x plus cos y means 2 cos x plus y by 2 into cos x minus y by 2. Similarly, this is minus 2 sin x plus y by 2 sin x minus y by 2. We'll apply these two transformations here. So if you apply this, you will get this as 2 cos 2x plus 6x divided by 2 cos 2x minus 6x divided by 2. Again here, if you apply this, minus 2 sin 2x plus 6x by 2 sin 2x minus 6x by 2. Solve this now. This is 2 cos 2x plus 6x is 8x. 8x by 2 is 4x. And here 2x minus 6x is minus 4x. Minus 4 by 2 is cos of minus 2x. And here again it is minus 2 sin 4x sin minus 2x. What is cos of negative angle? It is positive. Sin of negative is negative of sin. So this is here now cos 4x cos 2x. And here it is 2 sin x sin 4x, and here it is minus of 2 sin x. When you take minus outside, it becomes plus. So it is sin 2x. So now I'll separate the 4x terms. Next I'll separate the 2x term. So I'll take 2 cos 4x sin 4x. This as one term, and another term 2 cos 2x sin 2x. You can see here these two are in this form, that is 2 sin x cos x. What is this actually? This is the identity for sin 2x. Remember the formula of sin 2x? Sin 2x is nothing but 2 sin x cos x. But here you have 2 cos 4x sin 4x. That means you have to multiply 4 here, sin 4x cos 4x. So what happens if you convert this in the form of sin 2x? So what is the value of x here? Here it is 4x. So what happens? This is now sin 2 into 4x. That is sin 2x form. Again here also this is in the form of sin 2x form. But the value of x is here 2x. So into sin 2 into x. What is your x there? That is 2x. So when you multiply, it is sin 8x into sin 4x. So this is what we required. So you can see here, you want sine 4x and sine 8x, which is same as sine 8x and sine 4x. So I hope you understood the application of all those transformation formulas and trigonometric identities in these problems. So these type of questions may carry 3 or 5 marks in your examination. We'll solve few more problems on the application of those trigonometric identities in our next session also. Until then, keep watching, keep learning, and keep exploring. Thank you.